Hi everyone, my name's Calvin if you don't know me. I'm going to do a little demonstration to prove to you that the earth is flat and to prove to you that your belief in this imaginary globe earth is fictional. Now some of the tools I'm going to show you to demonstrate what we use in the construction industry. I can't think of any other industry offhand that uses levels and plumbs. Level datum lines and plumb datum lines. Level lines are horizontal, plumb lines are vertical. For every structure built on Earth, they would have used datum lines, level and plumb. So I'm going to explain to you now what tools that we have that measure level and plumb. And I don't know any, you could use these tools for measuring a curvature, but there is no curvature to be found, and that is what I'm asking. I want you guys to question all the kids and students to question your teachers, to dispute what I'm going to show you, and everybody would know somebody in the construction industry to question what I am saying. So one of the tools we use, first of all, for a level line and a plumb line, a modern tool is a laser. And how a laser works, it fires a beam of light out for the level plane, and it fires a beam of light for the vertical plumb plane. Now, you press one button, that's the line for the vertical plane, but as you can see, if you watch the laser itself, AJ, yeah, this laser, if the laser is not freely hanging, it will flash, because that means that it isn't at a level enough point to give an accurate line. You can see the line is flashing. Only once the laser is hanging freely, vertically, will the line stop flashing, and it will confirm that that line is completely level. The other line is the vertical line, which is this switch, which again will produce the plumb line, which is 100% vertical. Now, before we go any further, I want to show you, most people don't recognise that things are not level. Like, I know that these pair of door handles are nowhere near level with those pair of door handles, but most people wouldn't even notice it. You can't, to tell that something's level, like for example, if I wanted to put up a shelf here, how would I know that this shelf is level? I cannot measure from the floor, because the floor will 100% be not level. It will be leaning one way or the other, because in building, the floor levels and ceiling levels are not critical. So I know that they're not 100% level. So we cannot measure up from the floor, because I know it would be uneven. And we cannot measure down from the ceiling, because we equally know that it's uneven. So we need what's called a datum line. So let's say, for example, I want to put up a shelf on the wall. This is my shelf. It doesn't have to be wide, because I'm not putting anything on it. So let's say that we want to put up a shelf. But how do we know it's level? Obviously that's not level. But how do we know it's level? How do we know where is level? Yeah, we can't know. We can't measure from the ceiling downwards. We can't measure from the floor upwards. So we need a perfectly level datum line. Nowadays we find it with the laser. And the laser's for indoor use, by the way. Externally they use what's called a tripod, a theodolite, which is basically, it looks like a camera. It's on a tripod, and you'll see one guy looking through it, and you'll see another guy 50 yards or 100 yards away holding some sort of staff that has these sort of black and white markings on. But when you're looking with a naked eye, they make absolutely no sense whatsoever. But when you're looking through the theodolite, these are bang millimetre perfect measurements. When you see those people out on the street, ask them, question them, find out what they know. I'm telling you the truth. This is exactly how they use the tools. So going back to the laser, I'm going to set that piece of timber on that laser line so you know that my shelf is 100% level. Okay? So before we had the laser, I'm going to just switch that off for a minute. Before we had the laser, we had other things, and we still have today, spirit levels, which come in different sizes. Again, if you look at the bubble within the vial of spirit or liquid, you will see that it's level. The way the vial works is just basically a small clear tube filled with liquid or spirit. It leaves a bit of air in it, and when that bubble is bang center, they know that that's calibrated to be level. But before we had spirit levels, we used what's called a water level. Most people have never heard of a water level or even seen it or know how it works, and I'm going to show you how it works. But water doesn't lie, only man lies. A water level basically is this. It's a clear plastic tube. Doesn't matter the length, doesn't matter if it touches the floor or not. It's irrelevant. It can tell you from one point to another point that's level, providing the hose is long enough. The reason why you put the water in the hose, because the alternative is you would have to fill the room up with water, which is impractical. So what I'm going to do is I'm going to fill this with water, which is in the watering can. But to make it more visible, I'm going to add this closed dye, red closed dye, so that the water is more visible in the tube. So here's the closed dye. You know how rough it is or what it looks like. But basically, this is how a spirit level works. This is just an orange, clear orange bottle, orange juice bottle, filled practically to the top. Leave a bit of air in it. And then the air bubble, as you can see, is in the middle of the liquid. You see, that's how a spirit level basically works. Okay? So going back to our water level, water level works on the same premise. Here's the hose. We're going to fill it with water, coloured red. Doesn't matter how much you put in, doesn't matter how long the hose is. You can do it with a fatter hose, a thinner hose, it's completely irrelevant. The water will remain level in any container. Even inside this watering can, as I'm pouring it, the surface of the water will be level. In any container, glass, bowl, bath, swimming pool, pond, lake, even the sea. The sea level is level. As you can see, coming up the tube even together, level. You see? It's coming up the tube level. That'll do. So we've got our tube full of red water, and as you can see, you can move the hoses about, but the water inside will always be level. You see that? So how does a water level work? the water level works like this. If I wanted to just trying about it. Let me just to get the drill, 1 sec. We're just waiting for the water to stop rocking around. Okay, and the water when it comes to rest will be 100% level. So what I'm going to do is I'm just going to screw this to the wall. Now as you can see, I haven't got it 100% bang on, it's about 2 mil, 3 mil above the stick. But it doesn't matter because I know that the water level and the stick are both level. So when I move this end of the tube to that end of the stick, providing I hold the water level this 2-3 mil above this line, I know it's going to be 100% perfect. It's difficult to do on my own, to drill it, screw it and hold the hose. But hopefully that won't fall off of there. So if I take the hose over to here, it's all rocking over in it, but you'll have to wait for the water to settle. But once the water settles, you will see that both ends the water is exactly the same. Yeah. I'm trying to hold the hose still as well. But that's how the water level works. Okay? I'm offering £10,000 cash to anyone who can dispute this, how the water level works, and or how the spirit level works. Before we go any further, I'm going to leave that there, and I want to do a quick experiment showing you how these tools that I'm showing you only work on a flat level earth. So that's my flat level earth. To use the imaginary globe earth, that's exactly what you have to do, imagine. Anything other than imaginary just doesn't work. So I'm going to show you a quick demonstration of your globe earth theory. And to do the globe earth theory, you've got to use a lot of imagination, whereas the flat earth reality, it's all done in practice. So for the flat earth reality, I can show you reality, practical and theory, but for the globe earth theory, I can only show you theory. No, there is no practical and there is no reality. And I'm going to show you how. So just to get a fairly straight arc, I'm just going to do a quick drawing of your imaginary We go from our datum line, we'll say this is the line. This is where we are. This is me standing on. This is me. This is my flat earth on this side. And this is going to be your globe earth on this side. Sorry for the rough drawing. But basically, this is it. I should have drawn that line before I took it off. So this side we've got flat earth, reality. This side we've got globe earth, imaginary. And I'll show you why. Because all my tools, laser, oh, I forgot to show you also another tool, which is the plumb bob, which I'm going to show you now. Before we had the plumb line with the laser, we need to find out how that, we use a plumb bob, and obviously the name is in the clue. And basically it's just a weight on a piece of string. No matter where you hold it, high or low, it will always be 100% plumb. Once it stops moving, it will be 100% plumb. You can test that if you want by just holding it up against the laser. It will show you right there that the plumb line is 100% plumb. Okay? Right, let's go back to all these tools are used, the laser, the spirit level, the water level, the plumb line, they're all used for measuring levels and plumb used in the construction industry. So I'm going to draw a few houses on our flat earth, and we'll draw a few houses on our globe earth. Okay? We'll do equal houses, a little small one, a smaller one, and a wide one. In reality, using a laser or the spirit level, I could measure up from the line, or if I'm digging basements, I will measure down from the datum line. Again, with the vertical plumb, you would check the building with a plumb line, so you would aim the laser on the plumb line. Something like that. Just as an example, my drawing is not 100% because the laser proves it. Then we could check it on our taller building and our smaller building. But let's have a look on our globe earth building. Oops, doesn't seem to work. What about if we go further around the globe and have a look? Oh, doesn't seem to work. So we can't use this tool to measure, to build any buildings on a globe, but we can on a flat earth. The one that gives it away the most, well, we can use a spirit level, both horizontally or level, and vertically, or plumb. Yes? That's what the bubble in here tells us, that that is plumb. So we can use this to build our buildings and structures on a flat earth. But what about if we go to a globe earth? The bubble's not in there. It cannot be used for plumb. Or we can stick it on the top of the building, and you can see that we cannot use it for level. So we can't use this to measure anything on a globe earth. What about water? Water surely follows the shape of the globe in your imaginary belief, but in reality, water finds its lowest point on the earth. And if we were going to try and use our water level, go anywhere around the globe with it, you will see what happens in reality and not in imagination, because the water cannot lie. As you can see, the further I try and use this level round the globe, the water just pisses out. The water comes out. So you can't use a water level on your imaginary globe earth. You can only use a water level on a flat earth. So I ask all of you, question your teachers, question anyone you know in the construction industry. I'm offering £10,000 cash to anyone that can show me how you measure the curvature of the earth. Because all the tools that I know only measure and work on a flat earth. For the globe earth, you have to use what they tell us is approximately 24,000 odd miles around. You've got to use the formula to calculate this. It's 8 inches per mile squared. For example, 3 miles times 3 squared times 8 equals 72 inches, or 6 feet, and that's just over a 3 mile distance. So if you measure 3 mile, you should see 6 feet of curvature. That's how small they tell us the earth is. 24,000, I think it's 800 something roughly miles in circumference. That's the formula, 8 inches per mile squared. Do the numbers yourself, go out on the street and have a look. Everybody believes they're standing on the top of the ball, no matter where they are in the world. We can't all be standing on the top of the ball. Some of us must be ran further, but it's not proven, it's not measurable. Good luck everyone, have fun, the 10 grand's there. You can contact me directly, email me. I'll put the email on the link with the video, and you can email me any questions you want, any theories that you've got to prove your globe earth, imaginary globe. But in my world, in the reality, it's flat. All I can say to you is, welcome to the real world.